Good morning, students. This is our first lecture of our lecture series on mathematics for chemists. So, in this lecture series, we will learn some basic mathematics that will be useful in our chemistry to learn chemistry, especially physical chemistry. Today, the topic that I have chosen is very important topic, logarithm and logarithmic relations. Today we will learn what logarithm is all about, and we will learn some simple logarithmic relations. Some of you are already aware of these, so these lectures they are particularly helpful for the students with the medical background who do not came across these relations very frequently because they don't study maths after plus 2. So it will be quite helpful for them, and these are very important topics when we have to learn our physical chemistry. There they help us a lot. Now let us quickly define, let us learn first what logarithm is all about. Now here suppose I will write any exponential relation. Suppose a raised to the power n is equal to x. It is any exponential relation. A raised to the power n is equal to x. So we can also express this relation in terms of log. Then I will give you definition of log. Now if we have to write this relation in term of log, then we can write log with base a of x is equal to n. Now both these relations, a raised to the power n is equal to x and log of a log of x with base a is equal to n, both are same relations. This is called exponential relation or exponential form, and this is called logarithmic form of same relation. So what I can say, suppose if we have any exponential relation where a raised to the power n is equal to x, then log is defined as, we define log. So we define log of any number x with base a. So this which is written in subscript, it is called base. So log of any number x with base a is equal to n. So what does it mean? Its meaning, it comes from this exponential form, log of any number x with base a is equal to n. It means if we raise the base with the power n, okay, a raised to the power n, then its value will come out to be x. So that is the meaning of log. Log of any number x with base a is the power to which this base has to be raised so as to get this number x. So that's what I have written here. A raised to the power n is equal to x. If log of a is equal log of x with base a is equal to n, then it must satisfy this exponential relation. So that is the basic fundamental of log. If you learn this, if you learn this relation between log and exponential form, then half of job is done. The log is based on simply this relation, so then log is quite easy. You should be comfortable in converting exponential form and logarithmic form. Now as I explain, if log of x with base a is equal to n, then it means that if we raise this base to the power n, then we will get this number x, or log of any number with base a is the power to which this base has to be raised to get this number x. Now let us convert some exponential forms to log, then we will learn about log. Now suppose we have 2 raised to the power 3 is equal to 8. Now this is the exponential form. Now if we have to convert this to your logarithmic form, then we can write log of 8 with base 2 is equal to 3. So it is quite easy. That means log of 8 with base 2 is the power to which this base 2 has to be raised to get this 8. So if we raise 2 to power 3, then we will get 8. So that is the meaning of log. So that's how you can convert this exponential form to log form. It is quite easy. If you have to convert any exponential form is of this type to log, just first write log and the number to which we have some power, it will become base a. Now this result x will come here with the log, and the power to which this a is raised, it will go to right hand side. So that is how you can convert this exponential form to logarithmic form. It states a raised to the power n is equal to x. I am repeating again and again, that's why I am doing it again and again, because this conversion or this relation is quite easy, and it is quite important, because log is based on this formula, that how to convert this exponential form to logarithmic form. Now suppose if we have log of 10 with base 10 is equal to 1. Now if we have to write its what you call exponential form, then we can write this base raised to the power the right hand side 10 raised to the power 1 is equal to 10. That is how you convert this logarithmic form to exponential form. Or I will write once again, you can write log of 100 with base 10, that is equal to, let us say, 2. Then we can write it into exponential form. First we have to write the base 10, then we have to write the right hand side, which is 2. We will raise this 10 to the power 2, that will become equal to this number 100. So that is how you can convert this log to exponential form. This is called exponential form, this is called logarithmic form. Both the things, they are equivalent, you can write in any form, both means the same. Now let us do some examples based on this, then you can learn this. Now the first question is, it says that find log of 128 with base 8. So this 8 which is in subscript, it is called base, so we read it log of 128 with base 8. Now let us assume it is x, we have to find its value. Let us assume log of 8 with 128 is equal to x. Now if we convert this into exponential form, then we can write 8 raised to the power x, it will become is equal to 128. Now to find the value of x, it is easy if we convert these two numbers to the same base. Now 8 can be written as 2 raised to the power 3, so it is 2 raised to the power 3, it raised to the power x is equal to 128 is 2 raised to the power 7. So 2 raised to the power 3 raised to the power x, it is 2 raised to the power 3x is equal to 2 raised to the power 7. Now if these two are equal, they will be equal only if 3x will be equal to 7. So from here we can get the value of x is equal to 7 by 3. So it was quite easy, its value is 7 by 3. Now we have find the value of log with the help of this exponential relation. We have converted this log form into exponential form, then we had found the value of x, so it came out to be 7 by 3. Now let us do the next example. Now we have to find the value of x. If we have log 27, log of x with base 27 is equal to 4 by 3, then we have to find the value of x. So as usual, first convert this logarithmic form into exponential form. We will first write base raised to the power this right hand side 4 by 3, that is equal to x. So that will be your value of x. I have converted this logarithmic form to exponential form. Now 27 raised to the power 1 by 3 is 3. 27 raised to the power 1 by 3 is 3, its cube root is 3, so we can write it becomes 3 raised to the power 4 is equal to x, or we can say 3 raised to the power 4 is 3 into 3 9 into 3 27 into 3 81, 81 is equal to x. So value of x comes out to be 81, so we can write x is equal to 81. So again it was quite easy, we just had to convert this logarithmic form to exponential form. Now let us do one more similar example to this. Log of x with base 16 is equal to 5 by 4. We have to find the value of x. Again write the exponential form. 16 raised to the power 5 by 4 is equal to x. Now 16 raised to the power 1 by 4, its fourth root is 2. So 2 raised to the power 5, if we put the value of 16 raised to the power 1 by 4, it is 2. So 2 raised to the power 5 is equal to x, and 2 raised to the power 5 is 32. 32 is equal to x, or we can write value of x is 32. So these are quite easy exercises, and I hope with these exercises you might have learned how to convert this log form into exponential form, because this is the basic fundamental of this log. Once again I will tell you the definition of log. So log of any number x with base a is defined as the power to which this base has to be raised n, so that we could get this number x. So that is how with this definition, if you remember this relation, then you can give definition, or if you know the definition of log, then you can find the exponential form from this logarithmic relation. Now let us do some more exercises. Now it says that logarithmic of 1, log of 1 with any base is 0. So it is a generalization. The log of 1 with any base is 0. Now let us prove it. Now suppose base is a. Let us suppose any base a. Suppose, as he says that base is any number, so I have abruptly or randomly chosen base is equal to a. Now what he says, log of 1 with base a. So what we can write, log of 1 with base a. He says that its value is 0. We have to prove that log of 1 with any base or with base a is equal to 0. Now let us first convert this logarithmic form to exponential form. How we can write log of a? Now what I do, let us assume it is x. Suppose we don't know the answer, so what we will do, we will suppose log of 1 with base a is equal to x. I have chosen any abrupt number, I don't know its answer, I have assumed, suppose it is x. Now if we write its exponential form, it will be a raised to the power x is equal to 1. Now the only value of x which will satisfy this relation is 0. If x is equal to 0, then a raised to the power 0 is equal to 1. So if we have power 0 of any number, its answer is always 1. X raised to the power 0 is always 1. That is a mathematical relation. So this relation will only be true if x is 0. So x is 0, that means log of 1 with any base a is equal to 0, where a can have any value, 1 2 3 4 5 6 or any value. So the first generalization is log of 1 is 0 irrespective of the base be any, the log of 1 will always come out to be equal to 0. Next generalization, logarithmic of any number to the same base. So if number is same and base is also same, let us suppose number is a, we have to find the log of a. So base we have to, according to this, we also have to choose the same base is also a. Logarithm of any number to same base a, and base is also a. Then suppose we write its logarithmic form, log a and a. We have to find log of a with base a. We don't know what it will be. Let us suppose it is x. Suppose it is equal to x, then if we write its exponential form, so a raised to the power x is equal to a. We can also write a as a is equal to a raised to the power 1. So from here we write a raised to the power x is equal to a raised to the power 1. This will be true if x is equal to 1. So x is 1, so the answer is log of any number with the same base is always 1. If base and number they are same, then the answer will be 1. Like log of 10 with base 10 is equal to 1. Log of 2 with base 2 is equal to 1. Log of 100 with base 100 is equal to 1. So log of any number with the same base will always be 1. So its answer is 1. You have to remember this. So I have also proved this. Now let us see next. Says logarithm of 0. Now we have to find the logarithm of 0 to any base greater than 1 is now log of 0 to any base greater than 1. Suppose base is a, we have to find the log of 0. Suppose it is x, where a is any number greater than 0. A is any number greater than 0 because it says base greater than 1. So not 0, let us say it is greater than 1. Suppose it is greater than 1. So if base is greater than 1, then what will be the value of log 0? Now again write its exponential form. So a raised to the power x is 0. Now the only value for which this relation is true is x is equal to minus infinity. If x is minus infinity, then a raised to the power x is 0. Now let us see how. Now a raised to the power infinity, it can be written as 1 by a raised to the power infinity. So a raised to the power infinity is infinity and 1 by infinity is 0. So this is 0. So this is true when x is minus infinity. So the answer is minus infinity. Logarithm of 0 to any base greater than 1 is minus infinity. So these are some generalizations that you have to remember. So actually there is no need to remember. You can easily convert it into exponential form and find the answer. But in order to save time, it is better if you can remember this generalization, and these are not too difficult. These are quite easy. Now let us do the next relation. This is called product formula. It says that log of m cross n. N means m cross n. M multiplied by n is equal to log of m with base a plus log of n with base a. This is called product formula. Log of m cross n with base a is equal to, it is very important formula, it is equal to log of m with base a plus log of n with base a. Now let us prove this formula. Let us see how we can prove. Now is suppose in order to prove this, we will assume log of a with base m is equal to x. Let us suppose log of m with base is equal to x and log of n with base a is equal to y. Okay, is it clear? So log of a m we have assumed as x and log of a n with base a we have assumed as y. Now we will write their exponential form. Its exponential form will be a raised to the power x is equal to m, and its exponential form will be a raised to the power y is equal to n. So these are two relations that we have got from this logarithmic relation, or what we have assumed. Now we have to find log of m cross n. So what we will do next, we will find m cross n. It is equal to m is a raised to the power x, a raised to the power x into a raised to the power y. Now this is equal to a raised to the power x plus y. This is a mathematical relation. If base is same and we have powers, two powers, if we multiply these two numbers, then the powers they are added up. A raised to the power x into a raised to the power y is equal to a raised to the power x plus y. Now from this we have this relation m cross n is equal to a raised to the power x plus y. Now this is the exponential form. Let us try to convert this into the logarithmic form. This equation number 1, convert this equation number 1 to logarithmic form. It becomes log of a with base a of m cross n is equal to x plus y. It becomes log of m cross n with base a, it becomes x plus y. Now what is the value of x? From here x is log of a m and y is log of n with base a. So it is log of m cross n with base a, it becomes log of m with base a plus log of n with base a. So it is a very important formula. It is called product formula. It says that if we have the log of two numbers which are multiplied, then the result will be log of individual number, and we have to add those two values. Now from here we can find a generalization. If we have log of a a, let us assume x y is uh, any numbers p q r s and so on, so its value will be equal to log of a p plus log of a q plus log of a r plus log of a s and so on up to all the numbers. So this is called product formula. So we can write log of 6 as log of 3 cross 2 is equal to log of 3 plus log of 2. So that is your product formula. Similar to this, we have a quotient formula. If we have to find the log of two numbers which are divided by one another, so log of m by n with base a is equal to log of m with base a. Now we get here a negative sign. If these two numbers they are multiplied, then we get a positive sign. If they are divided, we get a negative sign. It is log of m with base a minus log of n with base a, means log of numerator minus log of denominator. Now let us prove again. This can be proved similarly. Let us assume log of m with base a is equal to x and log of n with base a is equal to y. Right there exponential forms, its exponential form will be a raised to the power x is equal to m, and its exponential form will be a raised to the power y is equal to n. Now we have to find m by n. So m divided by n is equal to a raised to the power x divided by a raised to the power y. So it becomes a raised to the power x minus y. So from here we have m by n is equal to a raised to the power x minus y. Now if we write its logarithmic form, it is written as log of m by n with base a, it is equal to x minus y. Now put the value of x and y. It is x is log of m with base a minus y is log of n with base a. So that is your quotient formula, which says that log of m by n is equal to log m minus log n. Now base is the same. It can be any base 1 2 3 4 5, any base, general base a. So this is proved similar to the product formula. So these are students, please remember these formulas. Mostly when we will do chemical kinetics, there these formulas they are quite useful. So you might have also you might also remember the first order kinetic equation, which involves log of this form, quotient form. So these formulas they are quite important. Now next generalization, it is called power formula, which says that log of m raised to the power n with base a is equal to this n. It comes before log, it is n log a log m with base a. So this is a very general formula. Log m raised to the power n is equal to n log m. Now let us try to prove it. Now again it can be proved similarly. Let us suppose log of m with base a is equal to x. Now what will be its exponential form? A raised to the power x is equal to y. Sorry, a raised to the power x is equal to m. This m, that is its exponential form. Now we have to find log of m raised to the power n. M raised to the power n is equal to m cross m up to n times. So what is m? M is a raised to the power x is equal to a raised to the power x into a raised to the power x into a raised to the power x up to n times. So it is a raised to the power x plus n times. So x plus x n times, it becomes nx. So it is a raised to the power nx. Now we have m raised to the power n is equal to a raised to the power nx. Now write its logarithmic form. This is exponential form. It becomes, its logarithmic form becomes, I will write here. So log m raised to the power n with base a is equal to nx. Now what is x? X is log of m with base a. So it is log of a, log of m raised to the power n with base a is equal to n log of m with base a. So that was, we have to prove log m raised to the power n is equal to n log m. So dear students, these are quite important formulas, and log is quite easy. So that was all about our today's lecture about log. In this lecture we give general introduction about log, and we learned how we can convert this a raised to the power n is equal to x, which is a exponential form, to log form. It is written log of x with base a is equal to n. So you should be able to convert log form into exponential form and exponential form into log form. And using these relations we solved some examples, and we did some very important logarithmic formulas like product formula, quotient formula, and power formula. In our next lecture we will do some more examples of log. Till then, thank you very much, and please also don't forget to subscribe my channel and also share with your friends. Thank you very much.